Okay, so we're continuing our work on proportions and proportional relationships. What makes two quantities proportional? So what are we talking about when we're talking about proportional? What could you relate it to? So let's say I have 1/2. What would be a proportional amount to 1/2? 2/4. Right? So proportional means you're keeping things equivalent, right? And so how did you know how to do that, Alexis? So they're the same. So the math that we could do is times 2 and times 2, right? So that's one way to prove those are proportional. Could you also cross multiply to prove two things are proportional? Yes, I could say 1 times 4 is 4, and 2 times 2 is 4. And when you cross multiply, if you get the same products, they are what? Proportional. Okay, so if you multiply the numerator and denominator by the same number, they're proportional. If I divided the numerator and denominator that way by the same number, they're proportional. Or if you do cross products and you get the same product, they are proportional. Correct? And we also said you could, this is the same thing as finding a common denominator. So a common denominator for 2 and 4 would be 8, right? And so 1/2 is how many 8s, and 2/4 is how many 8s. We could say times 4 and times 4. And here we could say times 2, and we could say times 2, and we're going to get 4. So we can also find common denominators, and if we get the same fraction. So proportions are directly related to equivalent fractions. Agreed? Yes? Okay. So let's go up and let's solve some problems using proportions. So, number 1. Sam raked 3 bags of leaves in 16 minutes. If he continues to work at the same rate, how long will it take him to rake 5 bags? So the key to this is to make sure that we understand this is the first proportion. 3 bags of leaves in 5 minutes. That's the first proportion. And does it matter if I put the bags in the numerator or the bags in the denominator? It really doesn't with the first one. If I'm going to a unit rate, it would. If I wanted to know how many bags per minute, then I would want the minutes in the bottom. But if I'm just trying to find how long will it take him to rake 5 bags, it doesn't really matter. What matters is if I put 3 bags here and 16 minutes here, what's important? In the equivalent proportion that I put the bags in the numerator and the minutes in the denominator. I could have switched these, but as long as I must see the units. Let me say that one more time. I must see something that shows the 3 is the bag and the 16 is the minutes. If you do not have that, it will be wrong. That is bad practice to just put numbers in there without a context or a unit. So, if he continues to work at the same rate, how long will it take him to rake 5 bags? Where is that going to go, the 5 bags? In the numerator or the denominator? Numerator, 5 bags. So, how many minutes? So, the key is bags, bags, minutes, minutes. Now, is there a nice way to get from 3 to 5? Can I multiply or divide 3 by anything to get to 5? Not a whole number. So what do you think we're going to want to do to solve this one? Cross multiply. We're going to say 16 times 5. And what do we get when we do 16 times 5? It's 80. And so when I cross multiply this, some number times 3, what should I get if they're proportional? 80. And so since I don't know what this number is, what am I going to do? Divide by 80 divided by 3. 80 divided by 3, and what is that going to give us? So what does that mean if it's 26 repeated? In real life, what would that mean? Would it mean exactly 26 minutes? It would be somewhere between 26 and 27 minutes. All right, questions on that first one? Is this new to us? Haven't we done some of these problems? Yes. Okay. Amy earned $25 after babysitting for 3 hours. That's our first proportion. $25 and 3 hours. If she always charges the same rate, that's important, the same amount per hour. If she always charges the same rate, that means we're talking about a proportion. How much will she make after working 7 hours? So, $25, 3 hours is how many dollars in 7 hours? I forgot my H with my 3. What's the math we want to do here? Cross multiply. 25 times 7. 175. And so 3 times something also has to equal 175. Do we know what that number is? How much? $58. And if the 3 repeats, 33 cents. With money, we can figure out what that means. $58.33. Since the 3 is repeating, you would round to the 3. I wonder why these are so, the fractions are so yucky, or the decimals. Try the setup on the next one. Let's put our money in the numerator. Let's put our money in the numerator. first two amounts. Good job, Ollie. So you have to have two amounts to be able to multiply together. So you started this way. Is that right? Okay, now what do you do here? If you don't know what you're multiplying by, what's the opposite of multiplying? Divide. So if you're having trouble kind of figuring it out, you can set up an equation that looks like an algebra problem. So let's do this. 125 in 2 months is how much money in 8 months. So this one is kind of where I could, what would I multiply 2 by to get 8? 2 times what is 8? 4. So I could have multiplied that by 4. Another way you can do it is say 125 over 2 is how much over 8. And so if we set these two things equal, we would say 125 times 8 equals 2 times x. Isn't that what we're doing? 125 times 8 equals 2 times x. Because if we multiply this, it's supposed to be equal to this. And what did we get 125 times 8 is? 1,000. So 1,000 equals 2x. And so how would I solve that? That's a one-step equation you've known how to do since 6th grade. What would I do? Divide by 1,000 or divide by 2? Divide by 2. You could divide by 2 and divide by 2, and that means x would equal 500. So you can set it up to where you just have an unknown. Or you could just do it this way. 8 times 125 is 1,000. And 1,000 divided by 2 is 500. So what is the total amount he will pay for 8 months? It is $500. So if you were to go do a lesson like this with Mr. Haskins in the Math Power Hour, he always sets it up like this, where you're solving for a variable. Some people find that easier. I have traditionally not found that to be easier. Most people just remember the cross-multiplying method. But we'll determine what works best for you. Everyone's work doesn't have to look the same. All right, let's try 4. Bobby drove 110 miles and his car used up 5 gallons of gas. That's our first proportion. 110 miles and he used 5 gallons of gas. How many miles can he drive with 16 gallons of gas? So 110, M for miles, 5 gallons of gas. How many miles, that's what we don't know, how many miles in 16 gallons of gas? Give it a try. Cross multiply and then divide. 110 times 16. $1,760, is that right? 1,760. 1,760 divided by 5? 352 miles. Ready for the last one? Mary ran 2 miles in about 23 minutes. If she continued at the same pace, how long will it take her to run 10 miles? So that is also another one that could be set up easier. 2 miles in 23 minutes. Now, what do you notice about the units on my first proportion? What if I had just used M for miles and M for minutes? You would be confused. So you need to make sure that you are doing something to differentiate the two. Normally miles is an M, minutes is M-I-N. So if you continued at the same pace, how long will it take her to run 10 miles? 10 miles in how many minutes? So this one, I could just say 2 times what is 10? 2 times what is 10? 5. So I could just multiply that by 5. Or I can say 23 times 10, using some mental math. That is what? 230. And then 230 divided by 2 is 115 minutes. So you can use whatever strategy you want on this. So you could have used the times 5 times 5. But I would normally recommend the cross multiply method because as we saw up here, there's nothing to get from, we had the 3 and we had the 7. There's not an easy multiply or divide to get back and forth. And so if you just know this cross multiply method, it's always going to work for you. Questions? Okay, let's put this in our journal and we're going to do a couple of problems on the skills practice together. And then you'll have plenty of time for working today. So we are on page 59. Is that right? Well, if you turn the page, 58's the back, and we don't glue on the back unless it's a special circumstance. So on the right is page 59, and that's where we're going to glue, right there. This doesn't have a title on it, so I'm going to write a title, Solving Proportions. On my page, I'm going to write Solving Proportions on my page. And that's going to be our title in our table of contents. Today is the 22nd. 11/22. And just, I'm gonna write the same thing right here. So 11/22, solving proportions, and that's on page 59. And this is what you're writing on the top of that page too, solving proportions. About 1 minute, and we're going to look at the skills practice together. Dominic, is your table of contents caught up to date? So if I looked at it, it would look like mine. Flip your notebook back over. I want to see the front folder. No. You see those papers right there? We turned those in for a grade. I think you were absent the first day we did it. But it's makeup work. You've got to get it done. All right, so let's take a look at the skills practice. Put your name on the top of the skills practice. I feel like I shouldn't have to say that to 7th graders, but in my experience, I do still need to say that. Put your name on it right now if it's not already there. That means you. Put your name on it if it's not already there. All right, here we go. The top just says determine whether each pair of ratios form a proportion. So it means they might be proportional and they might not be proportional. So the other day we had 3 different methods for deciding if something formed a proportion. What page was that on? 53. 53 in your journal if you're having trouble. Remember, there's 3 different methods. You could simplify the fractions. You could find the unit rate, or you can cross multiply and see if their cross products are the same. If the cross products are not the same, then they are not what? Not proportional. That's what we're going to use on this one. So 3 times 5 is 15. 8 times 2 is 16. So what would we say? No. They do not form a proportion. That's all we're doing on this one. And you can use a calculator. Okay? I'm not going to go any further on the top. You can use a calculator. You have to do all of them. That's it. Okay. Down at the bottom. These say solve each proportion. So that means they are all proportional. You are solving for this variable. So you could say 9 times 4 is what? 36. So 12 times what is 36? 3. Or you could say 36 divided by 12 is 3. So I want you to write it like this. Y equals 3. Does everyone know where that y came from? Because it's the variable right here. Or you could have said 36 equals 12y, right? We said 9 times 4 is 36. 36 equals 12 times y. You could have divided by 12. Divide by 12. Y equals 3. Either method works. I just don't feel like it is a good use of time to do this unless you don't understand what you're doing. Mr. Haskins does require his students to set it up like that. But you use whatever method works for you. Okay, let's look at number 28. Why does number 28 look a little bit more difficult? It has a decimal, but if you're using a calculator, is it really any more difficult? No, it's not. 5 times 6 3/10, what do we get? So I don't have a calculator, so 31 5/10. 31 5/10 divided by 18 is 31 divided by 18, 1.75, 1 75 hundredths. I knew it had to be bigger than just a decimal because 18 goes into 31 one time at least. X equals 1.75. So I do want all of these written in the form of the variable equals. Questions? Are there any others that you feel like we need to work out before you go on? These are not that different than what we've already been doing. Okay, look at the back. A 12-ounce bottle of shampoo lasts Enrique 16 weeks. How long would you expect an 18-ounce bottle of the same brand to last him? So I do expect to see, just like on our notes, set up the proportion. 12 ounces is 16 weeks. So 18 ounces would last him how many weeks? So what are we going to do? 16 times what? Times 18, and we get 288. And then 288 divided by 12. 24 weeks. And what do you notice that I did at the end of that? Right? It's a word problem, so it must have words in the answer. Go back and read the last sentence. How long would you expect an 18-ounce bottle of the same brand to last him? It should last 24 weeks. Your words do not have to be exactly like mine, but it should have 24 in weeks in there. Questions? So you were doing all of this. Front and no. Let's do even. You can do all of them if you want. But let's just do even. 2, 4, 6, 8, 10, 12. Got it? And so that means on the back, just this column. Questions? All right, come see me or Mrs. Bent if you have a question.